This script might seem to be production ready, but let's skim through the code and let's try to find a couple of bugs or enhancement opportunities. And right here we have one, that is fee. Here we have hard coded the fees, which is 12 drops, which might fail because whenever there is more load on the network, if you fix the fee as 12 drops, it's bound to fail at some point. So let's give the user the opportunity to select various fees depending upon the network load, and we will look at that in upcoming video. So let's scroll through and find some more stuffs. So here is the first one we need to fix, that is fee must be chosen by the user. So what's next? The balance here. This is not 100% accurate. There is something called owner count, which I skipped on purpose because it's hard to explain about owner count in the beginning itself. This whole thing calculates the actual balance in your account, okay? To calculate the spendable balance, we have to subtract the account reserve, which is 10 XRP as of now, minus the owner reserve is 2 XRP as of now, multiplied by, that is 2, that is owner reserve, multiplied by the number of objects present in your account, which I'll explain in upcoming videos. For now, this is how we calculate the spendable balance. So the owner count is present inside the data, which and inside account data field. Okay, so this is the spendable balance. Now let's copy this and add it to this number. So what it means is the total balance, this one, if the total balance is less than, it has to be less than, not equal to. If it's equal, then it's not a problem. So the total balance, if it's less than whatever the user is trying to send, plus the account reserve, plus the owner count present on that account. If it's less than the actual total balance, of course you can't send the XRP you are trying to send, okay? So that's one thing I wanted to fix, and I'll explain about owner count in upcoming videos shortly. And one more thing which we are going to see in this video is verification of transaction. So let me comment all this code and then remove this. Let me output the entire data. /n for new line. I think we have a missing brackets here. Yeah, we should remove this. Okay. Hope everything is fine. Let me execute this script. And it triggers the transaction event. Okay. So here, validate, oh, we have past last ledger and transaction is not seen thing being output to the console window. That is because I think we have even commented the client.close inside this client.on. Yes, that's right. Let me uncomment this line of code which fixes the issue. So let's rerun the script. So on transaction, we get this data, and here validated is true, and in some cases it will still be false, which means the transaction is successfully included in the transaction list, that is in the open ledger, but it's not being yet included in the closed ledger. And remember, the transaction is final only when it is successful and is included in the closed ledger. Okay, so in this case validated is true, but still we shall verify if this transaction was included in the closed ledger or not. For that we need this hash or the ID which we get when we sign the payload. For now we know hash has this transaction ID, so let me copy it. And then inside the event handling, I'll show you the library I'm going to use, which is xrpltx data. Okay, you can see the URL for this library here and the description here. It returns meta and balance detail if the transaction is indeed found in the closed ledger. So here is how it's used. This connects to full ledger servers. Where is the package? So if the transaction is not found, it will just output not found message, and if it's found, it will return the meta as well as parsed balance. So we need to install a package. Let me scroll up and find the package name, which is here, xrpl-tx data. We need to install that. Let me show you that. Copy it, and you already know how to install the packages. I'll show you one more time. npm install, or just npm I followed by package name. That's it. Now import this package with this name. Let me do that. From the package name, and we need to import tx data. Okay, only then we can create an instance of tx data. Now let me copy this. And you need to decide where you want to verify this data. For my case, for this script, it's good to try to verify if the transaction was included in the final validated ledger at this spot wherein we are handling transaction event. One more thing, while we created this client instance, we passed this WebSocket URL as a string. If we don't pass it, it gets connected to the mainnet. And optionally, you can even pass the WebSocket URLs as a array of strings, that is 3 WebSocket URLs. The first one being the main WebSocket and the 2 being the failover WebSocket URLs. Similarly here, if you don't pass anything, it will just get connected to the main network, or else you can pass, if you have your own WebSocket URLs, you can just pass it like this. If you don't pass anything, it gets connected to the main network, and it has 3 WebSocket URLs, which is one main one, and the 2 are failover WebSocket URLs, which I'll show you in this document itself. So how to use this instance? We have it here. We can use get1 method present inside the instance. Let me paste it here. If you want to retrieve the details of only one transaction, you can use get1 method. Now this method returns a promise. So how to use this inside a normal function? You could just add async here. Before that, let me remove this dummy hash and replace it with the real one, which is present inside data.transactionsfield.hash. Okay, so now you could simply add async keyword here, or else if you have a function wherein you don't want to add async to it, you have an alternative here. Just write an anonymous function which calls itself and make it asynchronous. That's it. So this is how to do it. Now inside this, write your method which returns promise. That's it. This should work. Now if you have multiple hashes of which you need to retrieve the details of, you should just use txd.get method, which is here, as you can see. But in this case, if you want to retrieve multiple transactions details, the script doesn't know when you want to stop retrieving the data. So you need to explicitly end the WebSocket connection by writing txd.end. And these are the default WebSocket URLs you will be connected to if you don't mention the array explicitly by yourself like this. If you want to get connected to some other full history servers, you need to just specify that inside the array. And the second parameter is endpoint timeout, that is reconnecting to the server if there is any failovers. Okay, and if the transaction is not found, you'll get not found message. If the transaction is indeed found, okay, you will get this response with meta and balance detail. You will get the meta, that is the accounts being affected by this transaction, and then the balance changes, the both accounts. If one account is sending a payment, it has to send to another account. So there are two accounts involved. If the value is negative, that means it's the sender. In this case, 1.000012, the decimal part is the transaction fees, and 1 XRP is being sent to this address. And this one is a transaction detail of DEX, that is order execution, which is a little bit complicated, and we will see this kind of examples, that is DEX transaction examples, in upcoming videos. So this is how you programmatically verify if your transaction got included in the closed ledger or not.